Good morning to one and all present here. Today we are going to see the topic of volume. First of all, let us have a basic understanding regarding what is volume. Now, suppose we have a solid shape. We know that any solid shape occupies an space. This space occupied by this solid is called volume. Let us take one more solid shape, this water bottle. Now, as we can all see that this water bottle is in the form of a cylinder and there is some internal space occupied by this solid. So, this internal space that is occupied by the solid is also called volume. So, we can define volume as internal space occupied by any solid. I would like to repeat once more. This duster is a solid. It is occupying certain internal space. This internal space occupied can be called volume. In the same way, this water bottle also occupies some space internally. This is called volume, can also be called as capacity. Let us see the volume of cube and cuboid with their formula. As we know that cube is 3D form of a square, because we know that in a square all sides are same. In the same way, in a cube all sides will be the same. Now suppose we have a cube here and I tell that all the sides are L. So what will be the volume of this cube? Volume of this cube will be L into L into L, that is length into length into length. So volume of cube will be L cube. I repeat, volume of cube will be L cube. Now, we also know that cuboid is the 3D form of a rectangle. Now, if I say that this cuboid has three basic sides, length, breadth and height. So, the volume of this cuboid can be written as length into breadth into height. That is L into B into H. So, I repeat once more. Volume of a cube will be L cube. Volume of a cuboid will be L into B into H. Now, let us take one example. Suppose I have a cube whose length is 5 cm and I am asked to find out its volume. So, what will be the volume of this cube? Volume of this cube will be L into L into L, that is 5 into 5 into 5. And as we all know that 5 into 5 is 25, 25 into 5 will be 125, and because we are using volume, because we are involving three sides, unit of this volume will be 125 centimeter cube. Let us see one more example for finding out the volume of cuboid. Suppose we have a cuboid whose length is say 6 centimeter, breadth is say 4 centimeter, and let us say that the height is 2 cm. And we are asked to find out the volume of this cuboid. So, as per the formula, we are getting that volume is equal to L into B into H. That is L is 6, breadth is 4 and height is 2. So, 6 4s are 24, 24 2s are 48, and because the unit is in centimeter, volume will be 48 centimeter cube. So I hope you are all able to understand the formula of volume of cube, that is L cube, formula of volume of cuboid, that is L into B into H. Let us see the first sum from this textbook, exercise 13.5, first question. I would like to read this question first of all. I read the question first from this exercise. A matchbox measures 4 cm into 2.5 cm into 1.5 cm. What will be the volume of 12 such matchboxes? I repeat my question. There is a single matchbox whose dimensions are 4 cm, 2.5 cm and 1.5 cm. We have to find out the volume of 12 such matchboxes. So let us have a look. Now, because the dimensions are 4 into 2.5 into 1.5, we can assume that length will be 4 cm, breadth will be 2.5 cm and height will be 1.5 cm. And as you all know, we are required to find out the volume of 12 such matchboxes. So what we should do? We should first of all find out the volume of a single matchbox. So volume of one So what was the formula of the cuboid that we have discussed? It is L into B into H. So let us find. L is 4 centimeter, breadth is 2.5 centimeter, and height is 1.5 centimeter. Now, if we are multiplying them, we are getting 4 into 2.5. What is that? It is equal to 10 into 1.5. And if we solve this, we are getting 10 into 1.5 equal to 15, and because the unit was centimeter, volume of a single matchbox will be 15 centimeter cube. This is not the final solution because we have found out the volume of a single matchbox. We need to find out the volume of 12 such matchboxes. So, volume of 12 matchboxes equal to 12. What was the volume of a single matchbox? 15. So 12 into 15 equal to 180 centimeter cube. So this is our final answer. Volume of 12 matchboxes will be 180 centimeter cube. Students, let us see the second question from the exercise. I would like to read the question first. A cuboidal water tank. Mark my words, it is already given in advance in the question that the shape of this thing is in the form of a cuboid. A cuboidal water tank is 6 meters long, 5 meters wide, and 4.5 meters deep. Now, in case you have some confusion, depth can be taken as equivalent to the height. So we will say that length is 6 meter, width is or breadth is 5 meter, and height or depth is, we can say, 4.5 meters. Now, we are asked how many liters of water can this tank hold. So first of all, what we will do, we will find out the volume of this water tank. First we will note down the figures that are given in the question. Say length is 6 meters, breadth or width is 5 meters, and as we can see, the depth or the height can be taken to be 4.5 meters. So first of all, let us find out the volume of this water tank. Because it is in the shape of a cuboid, the volume formula will be L into B into H. Let us put down the values. 6, breadth is 5, and height is 4.5. Now we all know 5 into 6 30. 30 into 4.5, if we are solving in rough, 45 into 3. The answer will be 135, and because the unit is in meter, the answer will be 135 meter cube. But students, this is not the final answer because we have to read the question. How many liters are asked? Now, we have not got the answer in liters, we have got the answer in meter cube. So, I would like to just take your point to a very important relation. That relation is 1 meter cube equal to 1000 liters. 1 meter cube equal to 1000 liters. We are asked to find in the question how many liters of water we can have. As we are saying that 1 meter cube is equal to 1000 liters, and whatever answer we have obtained is in meter cube. So to find out the answer in liter, what we will do? 135 into 1000. So what we are getting? 1,35,000 liters. Our final answer would be the water tank can hold up to 1,35,000 liters of water. Okay, so let us see the third sum of this exercise, that is question number 6. Before I go on with the details, let me read the question first. A village having population of 4,000 requires 150 liters of water per person per day. I would like to repeat, there is a village whose entire population is of 4,000 and water requirement for a single person, that is per head, per day is 150 liters. Now, let us move ahead. Requires 150 liters of water per head per day. It has a tank whose dimensions are 20 meters into 15 meters into 6 meters. Now the question is, how many days will the water of this tank last? Let me review the question once more. There is a village that is having entire population of 4,000. Water requirements for each person per day is of 150 liters, and there is a water tank in that village that is mostly cuboid because of the dimensions, and the dimensions are 20 into 15 into 6 meters. Our question is, we have to find out with this capacity or with this availability of water, how many days the water will actually last. This. Now, let us first of all find out the volume of this water tank that is available. And because we know that this water tank is in the shape of a cuboid, the volume's formula will be L into B into H. So putting up the values, that will be 20 into 15 into 6. Now we know that 15 to the 30, that means 15 into 20 will be 300 into 6. 6 3s are 18. So 6 into 300 will be 1800. What was the unit given in the question? Meter. So this will be meter cube. Now because students, we are dealing with water and the unit of this water available is in liter. So please remember the previous question I gave you this relation that 1 meter cube will be equal to 1000 liters. So if we are using this you can say relation for this, 1800 meter cube will be equal to 1800,000 liters of water. So this is the entire amount of water that is available in the water tank. This is first part of the question. Now for the second part of the question, we are told that there are 4000 people and each day each person requires 150 ml or 150 liters of water. So total water required, what was the entire population of the village? That was 4000. And how much water does each person require per day? That is 150. Now 15 fours are 60. So the entire water requirement will be 60. Okay, that will be equal to 6 lakh liters of water. So this is the required water by each person each day. Now we have to find out how many days the water will last. So what we will do, we will just divide these two values that is obtained. Which are the two values I am talking about? First is the amount of water available in the water tank. Second is the amount of water required by each person of the village. So number of days water will last, that will be equal to 18 upon total water requirement. Now eliminating these values, we are left with 18 and 6, so we can easily see the number of days the water will be last will be 3. So this would be our entire solution. I repeat the solution. We have to find out the dimensions of the water tank first of all. We then find out the amount of you can say water that is required for each person during each day, that is equal to 6 lakh liters. And finally we find out how much number of days the water will last for each person, that is 3 days.